Okay guys, what's going on? We have another physics problem, and this one is a little bit tricky, so we have to go through it. There's different ways to do it, but I will show you my way. I got the right answers. If anybody has different ways to do it, you guys welcome. So it says he assumed the conduction of electrons in a metal can be treated as a classical practical particles in an ideal gas. What is the root mean square velocity of electrons in a room temperature copper? And how far on average does an electron move between collisions? So this one, let's say we start with A, and it says that root mean square velocity equal square root of 3 Boltzmann constant times temperature in Kelvin divided by the mass of the electron. Okay, because they're asking us the velocity of an electron. So we know the room temperature is 25 degree. So to convert this to Kelvin, we just gonna add 273 Kelvin, and this one will give us almost, we're just gonna round to 300 Kelvin. Okay, so the velocity of this is gonna be 3. Boltzmann constant is 1.38 power of 10 minus 23 multiplied by 300 Kelvin divided by the mass of electrons is 9.11 times 10 minus 31 power of 31 kilogram. Okay, and this velocity will give us 1.1 power of 5 meter second. Okay, we go to number B, and it says how far on average does an electron move between collisions. This one I use the lambda, the wavelength formula, that equals the velocity divided by frequency. We know that frequency is 1 over time, so lambda will equal speed times time. Okay, and to find time we can use the conductivity formula, and that's Ne multiply, Ne actually is the conduction electron density of copper multiplied by the electron charge square multiply by the time divided by the mass of the electron. So the time here will equal 2.5 times 10 minus 14 power of minus 14 second. Okay, and then we're gonna do the lambda equal the speed that we have 1 times 10 power 5 multiplied by 2.5 power of minus 14. So the lambda will equal 2.75 power of minus 9 Okay, meters second square. And then we can use that. We know that lambda of the wavelength is 2 length of the number of the first wavelength. So this one will equal 2.75 power minus 9 equal 2 L divided by 1. So the length will equal 1.4 times 10 minus power of 9.